Ever pondered about how fast light travels? Well, it's time to unravel this cosmic speed limit. Welcome to the fascinating world of light speed, a concept that has intrigued scientists and enthusiasts for centuries. It's not just a number or an abstract concept, but a fundamental law of physics that governs the very fabric of our universe. It's the ultimate speed limit, beyond which no information or matter can travel. To put it into perspective, imagine this. The speed of light is so fast that it can travel around the Earth 7.5 times in just 1 second. It's this speed that allows us to see the stars as they were millions of years ago. And it's this speed that determines how we understand the universe around us. But why is this speed so significant? Well, for starters, it's not just about how fast light moves, it's about the fundamental nature of space and time. You see, light doesn't just travel, it defines the very structure of space-time, the four-dimensional fabric of our universe. Moreover, the speed of light is deeply entwined with Einstein's theory of relativity, which revolutionized our understanding of the physical world. It's the constant c in the famous equation E=mc², which tells us that energy and mass are interchangeable, and that the speed of light is the conversion factor. And it's not just in the realms of physics that the speed of light plays a crucial role. It's also a key player in technologies we use every day, from GPS systems that rely on the constant speed of light to calculate distances, to fiber optic cables that carry internet data at near light speed. So, when we talk about the speed of light, we're not just talking about a physical phenomenon, we're talking about a fundamental aspect of the universe, a cosmic speed limit that shapes our understanding of everything, from the smallest particles to the vast expanses of the cosmos. So, the speed of light isn't just about how quickly you can switch on your lamp. It's a fundamental aspect of the universe itself. What exactly is this speed we're talking about? Let's bring it down to Earth. Imagine you're sitting at your breakfast table, enjoying your morning coffee. You glance out the window and see the sun rising, bathing your world in light. But have you ever stopped to think about how that light reaches you? You see, light has a speed. It doesn't just instantly appear as if by magic. It has to travel, just like a car on a highway or a bird in the sky. And the speed it travels at is mind-bogglingly fast. We're talking about approximately 186,000 miles per second. That's nearly 7.5 times around the entire Earth in just 1 second. But let's make it even simpler. Picture a beam of light leaving the sun. Now, the sun is pretty far away, right? About 93 million miles from Earth. But that beam of light, it's so fast that it can cover that entire distance in just about 8 minutes and 20 seconds. That's less time than it takes to boil an egg. Think about it. When you're basking in the sun's warmth, you're feeling the effects of a journey that started on the sun's surface just a few minutes ago. It's a journey that spans the vastness of space at a speed that makes our fastest rockets seem like snails in comparison. And it's not just the sun. The light from the nearest star to us, Proxima Centauri, which is over 4 light years away, takes over 4 years to reach us. So when you look at that star, you're actually seeing it as it was over 4 years ago. So when we say the speed of light is fast, we mean it's seriously mind-blowingly fast. It's a speed that's hard to comprehend, but it's fundamental to our understanding of the universe. And that, my friends, is why we say the speed of light is seriously fast. But how fast, you ask? Let's delve deeper. Numbers speak louder than words, so let's talk digits. When we say light speed, we're talking about a velocity that's almost unfathomable. In the metric system, which is used by scientists worldwide, the speed of light is approximately 300,000 kilometers per second. To put that into perspective, if we could travel at the speed of light, we could circumnavigate the Earth roughly 7.5 times in 1 second. Now, if you're more comfortable with miles, it's about 186,000 miles per second. That's like traveling from the Earth to the Moon in just over 1 second. It's a speed so fast, it's almost incomprehensible. But let's try to make sense of it with some everyday comparisons. Picture your car. On a highway, you might hit 100 kilometers per hour or about 60 miles per hour. If you kept that pace up, Day in and day out, it would take you over a year to travel the distance light covers in 1 second. Or consider a jet plane cruising at 900 kilometers per hour or about 560 miles per hour. Even at those dizzying heights and speeds, it would still take you over a month to match what light accomplishes in 1 second. These comparisons reveal just how staggeringly fast the speed of light is. It's a speed that, until we find a way to bend the laws of physics, remains an unachievable ideal for us humans. So next time you're in a hurry, remember, even light, the fastest thing in the universe, takes its time to travel. Ever wondered why nothing can outrun light? There's a scientific reason behind it. To understand this, we need to dive into the realm of Einstein's theory of relativity. This theory, which Einstein introduced in the early 20th century, revolutionized the way we think about space, time, and motion. The theory of relativity tells us that the speed of light is a constant, about 186,000 miles per second in all frames of reference. What that means in simpler terms is that no matter how fast you're moving, light will always pass by you at this same speed. It's a bit like trying to win a race against a runner who always runs at top speed no matter how fast you're running. Now, let's imagine for a moment that you could travel faster than light. According to relativity, your mass would become infinite and time would stop. That's right, time would stop. It's a mind-boggling concept, but this is what the math of relativity tells us. So, why can't anything go faster than light? Well, it's because the laws of physics as we understand them prevent it. The energy required to accelerate an object increases the faster that object goes. And beyond a certain point, specifically the speed of light, that energy requirement becomes infinite. In other words, it would take an infinite amount of energy to push an object to or beyond the speed of light. That's a tall order for any spacecraft or particle accelerator. In a universe governed by relativity, the speed of light sets a hard limit on how fast anything can go. It's not just a speed limit, it's a fundamental aspect of the nature of reality. So, as it turns out, the speed of light isn't just a limit, it's the ultimate speed limit. So, what does the speed of light have to do with you? More than you might think. The speed of light isn't just a fascinating scientific concept. It's an integral part of our everyday lives. It influences everything from the technology we use to the way we perceive the world around us. Let's take GPS systems, for example. These handy devices that guide us to our destinations rely heavily on the speed of light. GPS satellites send out signals that travel at the speed of light to your GPS receiver. The time it takes for the signal to reach the receiver is used to calculate the distance to each satellite, and with that information, your precise location on Earth can be determined. But it's not just GPS systems. The speed of light also plays a pivotal role in telecommunications. When you make a phone call or send a text message, that information is converted into light signals that travel through fiber optic cables at, you guessed it, the speed of light. This is why you can have near instantaneous communication with someone on the other side of the world. And let's not forget about our perception of the universe. The stars we see twinkling in the night sky are not as they appear right now, but as they were when their light started its journey to us. Some of those starlights have been traveling for millions of years, meaning we're essentially looking back in time. That's the power of light speed. Our understanding and utilization of the speed of light has opened up a world of possibilities, from exploring the far reaches of the universe to enhancing our everyday technologies. So, next time you use your GPS or make a phone call, remember you're harnessing the power of the speed of light. And that's the speed of light for you. Not just a cool science fact, but a fundamental part of our daily lives.